Okay, we have another example to look at today, another polynomial. So again, the very first thing that we want to do is to figure out what the domain is. And for a polynomial, it's always the same. Our domain is all real numbers, so negative infinity to positive infinity. And then the end behavior, again, a polynomial, we've got 4 options. So which of the 4 options are we in? We have an odd degree and a positive leading coefficient, so that means it is rising from the left to the right. Okay, the next thing we want to find is our y-intercept, and we find that by plugging in x equals 0, and in this case we get 0, 0. And the x-intercept, our last example, our function was already factored for us, and this one is not, so we need to factor it. So we can take out an x, and that leaves us with x to the 4th minus 5. Setting both of those factors equal to 0 to find our intercepts, we get 0, 0. On the other one, we would need to add the 5 and take the 4th root, and since the 4th root is an even root, that means we need a plus or minus. So, and we have the negative 4th root of 5 and the positive 4th root of 5, which may seem like a weird number, but the 4th root of 5 is approximately 1.5, so it's not too bad. Okay, those are the 4 things we get from our original function. The next things we need are where our function is increasing, where our function is decreasing, if we have any maximums, and if we have any minimums. So to find our derivative, let's use the original x to the 5th minus 5x, and let's just do power rule. So we get f prime of x equals 5x to the 4th minus 5. We can factor out a 5, and so we get 5 times x to the 4th minus 1. So we need to find the critical numbers. Those are our fence posts. So what are our critical numbers here? We get plus and minus 1. So f prime, we have a fence post at -1 and at +1. So let's test -2, and if I plug that into my derivative, I am going to get a positive number. Since it's the derivative, that means it is increasing. My next interval, let's try 0. If I plug 0 into my derivative, I will get a negative number, which means my function is decreasing. And then my last interval, let's try x equals 2. I plug that in, I get positive, which means my function is increasing. So we go from increase to decrease to increase. That means we will have a max at 1, or -1, and a min at +1. So our increasing intervals are negative infinity to -1, and also 1 to infinity. We are decreasing between -1 and +1. We had a maximum at -1. Now the maximum is a point on the graph, so to find the y value you need to plug in -1 to the original, and what do you get? You get 4. And then we have a minimum at +1, and again that's a point on the graph, so I plug in 1 to the original, and what do I get? -4. So remember, for the past 3 weeks we've been looking at increasing, decreasing, maximums, and minimums. We're still doing the same thing now. Okay, the last bit of information we need is where's our graph concave up, where's our graph concave down, and do we have any inflection points? So we need the second derivative to do this. So let me rewrite my first derivative. It was 5x to the 4th minus 5. And if I find the second derivative of that, well, I'm just going to get 20x to the 3rd. So what is my fence post on my second derivative test? Just 0. That's the only place this is 0, and it's defined everywhere else. Alright, let's try -1. And we need to plug this into the second derivative. So if I do that, I get a negative, which means it's concave down. And then let's try x equals positive 1. And if I plug that into the second derivative, I get a positive, which means it's concave up. So our graph is concave up from 0 to infinity, concave down from negative infinity to 0, and it has an inflection point where it changes concavity, which is at 0. And to find the y value of that, because it is a point on the graph, we plug it into the original function, and that's going to be 0, 0, same as our y-intercept. So this is everything we need. First derivative test for increase, decrease, max, and min. Second derivative test for concave up, concave down, and inflection point. And now I'm just going to graph all of this. My numbers are, my y and x values are pretty good here, so I'm just going to use the standard 1-by-1 grid that I have. I had an y-intercept at 0, 0. And then the 4 through to 5, remember that was about 1.5, and I've got a positive 1 and a negative 1 there. And then I had a maximum at negative 1, positive 4, and a minimum at positive 1, negative 4. My inflection point was at 0, 0. So my graph is increasing up until the max of negative 1, and then it's decreasing between the max and the min, and then it goes to increase again. And for the left half, it's going to be concave down, and then for the right half, it's going to be concave up. So something like this is concave down, and then something like this, concave up. So there's a general sketch of my graph using my first and second derivative test. And again, you should practice these without using a graphing calculator because you will not be allowed to use one on your assessment. All of the increasing, decreasing, concave up, max, min, inflection points, you've already been doing these, and now you're just applying them to sketch the graph.